Okay, hello everyone. So today I will do the review session. So before starting this, do you have any question? Yeah, if you don't have a question, then I will just start it. But if you have, then please let me know, right? So in the number one, okay, can you see my screen? Great, yes. In number one, given x is equal to 100 mod 10 and y is equal to 77382 mod 8 and g is equal to 32771 mod 7, and we want to find the value x plus y plus g, right? And for first of all, you know that actually 100 is just multiple of 10, right? It is 10 times 10, so x should be 0 because 100 is 10 times 10. And to get y, you can just divide it by 8, right? So if you just divide it by 8, then 8 times 9 is 72, and 53, and 8 times 6 is 48, so 5, 8, and 8 times 7 is 56, and 8 times 2 is 16, so the remainder is 6, right? So y is 6. Or if you have your calculator, then you can just get this remainder a little bit faster. So for example, if you just, in case of, dealing with z, just first calculate that, calculate 3200, sorry, 32771 divided by 7. Then if you just divide it by 7, then what you can get is 4681.571, something like that, right? So if you just put your calculator to divide this number by 7, then you can get this number. So it means that actually, this remainder part is actually here, right? So to get the remainder part, what you need to do is just original number minus 7 times 4681. And if you just calculate this number, then what you can get is 4, right? So that's how got your remainder using your calculator. So in case of if you are taking the exam using the Anorak, then in Anorak, I will give you, a calculator in on-screen mode, so you can use your calculator to get the remainder. Right, so G is 4, so X plus Y plus G is 10, right? Okay, do you have any question? Yes, are you going to post this? Yes. Okay, question? So answer is 10. Yeah. So, and okay, answer is 10. Okay, do you have any other question? Okay, then let's go to next. So in the number 2, we have 3-digit code A1, A2, A3, each appended with the check digit. A4, which is just 3A1 plus 13A2 plus 20A3 mod 5. Okay. Yeah, okay. So appended and check digit is A3 mod 5. And first problem is what is the check digit of 1 to 3? Then you can just calculate it by applying 1 to 3 on A1, A2, A3. So it is 3 times 1 plus 13 times 2 plus 20 times 3 mod 5. Then you can, yeah, this one is just 3 and this one is 26 and this one is 60. So it is 29 plus 60. So it is 89 mod 5. Yeah, don't forget to write down mod 5. And we know that 89 mod 5 is 4 because, 85 is multiple of the 5. So if you're just dividing this by 5, then you can get it is 85 plus 4. So that's why the answer is 4. Right? Right. Okay. And next problem is, can you find the missing value of the code word 32x3? If yes, then write y, otherwise write n. So to figure out, whether we can find it or not, just try to find it, right? So to do this, first of all, we know that our A4 is 3, right? It is already given in the program because the missing number is in the A3, but A4 is already determined as 3, right? So A4 is 3, and this A4 should be the same as 3 times 3, because A1 is 3, already given, plus 13 times 2, because A2 is already given. And since we don't know what the x is, so it is 20x mod 5. All right. Then 3 times 3 is 9, and 13 times 2 is 3 times 2, 6 plus 20 plus 26 plus 20x mod 5. And if you just add 9 and 26, you can get 35 plus 20x mod 5, right? But here, 35 is definitely multiple of 5, right? So you can get rid of it, right? Because it is multiple of 5. And also, this 20 is also multiple of 5, so it is just nothing but 0, right? So you can change it as 0 and change it as 0. Then the remaining one is just 0, right? So if there is some missing value x exists, then 0 should be the same with 3, right? But that's impossible because 0 is definitely, not the same as 3. So therefore, this code word is not buried. So we cannot find x, which making the code word is buried, right? So the answer is N. Okay, do you have any question on this example? Oh, okay, yeah. So I don't know how to, I will just put everything goes up. So how do we type that in a blank on WebAssign if our answer is 0 mod 5? Just, yeah, in case of, 0 mod 5 is the same as 0. So for example, 5 mod 5 is same as 0. 0 mod 5 is just same as 0. Minus 5 mod 5 is just same as 0. So in that case, just write down 0. So if you say something about that A mod B, then you can just change it to some number which is remainder of A divided by B. Then the remainder should be just from 0 to less than B, right? So then you can just write down remainder without mod thing to answer as some of the problems are multiple choices, but some of the problems are just, like this short answers. So in that case, just write down, 0. Do you have any other question, or Abid, does it make sense? Okay, great. Okay, then next question is 3215 valid? If yes, then write Y, otherwise write N. So I want to check that whether this number is valid or not. And to check this, what we need to do is just check that our A4, okay, our A4 is the same as the check digit formula, right? 3 times 3 plus 13 times 2 plus 20 times 1 mod 5. But yeah, so maybe you can just calculate these numbers, but without calculation, you can actually get some answer. Can you see that answer without calculation? To see this, you know that this is something is just the remainder by dividing some number by 5, right? But is there any remainder which is the same as 5 if you just divide some number by 5? Definitely not, right? Because 5 cannot be a remainder because 5 is just same as 5. Remainder should be the remainder of B, for example, remainder of some number divided by 5 is 0, 1, 2, 3, 4. So not 5. So A4 cannot be 5. So therefore, this is not a valid code word, right? Does it make sense? Okay, Abhi, do you have any question? Or if you think that it is a little bit difficult, then you can just calculate this one and find the answer.
So I think I did that incorrectly on the review because I was looking at question 2 and I was looking at the missing number. And then I went down to 3 and I thought, well, if the missing number, it could be 1, but the last one was 3. So then I said it was not valid because of that, because I thought they were connected. So I was confused.
Okay.
I got the right answer, but not the right way.
Yeah, I understand. Yeah. So I understand. Yeah. So yeah, that's good guess. But yeah, but all programs in the exams will be just separated. If it is related, then I will definitely mention it in the program.
Appreciate it.
Yeah. Thank you. And Abby, I thought we are going to continue 9 plus 26. Yeah, 1 mod 5 is the final answer, but 1 is not the same as 5, right? So what we need to find in number 3 is this code word buried or not, right? So, but this code word is not buried because if you just put 3 to 1 in the check digit, then check digit should be 1 as you find. So 3211 is buried code word, but 3215 is not a buried code word. Yes, remainder number mode 5, it cannot be 5. Yeah. And yeah, Katie, and 5 is a multiple of 95. 5 is a multiple of 5, I think, because 5 is a multiple of 95. But yeah, so yeah, that's the reason that it is not buried, because if it is some remainder, then it should be less than 5, right? Because we just divided something by 5, so remainder should be less than 5, strictly less than 5. Does it make sense? Okay. Okay, then let's deal with number 4. So in number 4, we catch the single digit error of third digit. Explain your answer. So okay, it requires some more pages. I just write down here. This catch the single digit errors on third digit. And to see this, what you can do is just write down correct code, which is A1, A2, A3, A4, and write down incorrect code. Here, A1, A2 is the same, but we have single digit error on third digits. So in this case, we need to write down E3 instead of A3, and A4 is the same. Then check digit, you need to calculate check digit of correct code. It is just A4, but it is just determined by 3A1 plus 13A2 plus 20A3 mode 5. And check digit of incorrect code is, again, it is the same A4, but this is 3A1 plus 13A2 plus 20E3, not A3, because we have E3 on the third position, and mode 5. So and if you just write down those check digits, then compare or simplify equations, then it is just 3A1 plus 13A2 plus 20A3 mod 5 is equal to 3A1 plus 13A2 plus 20E3 mod 5. Oh, sorry, I will write down it more clearly. Okay. 3A1 plus 13A2 plus 20A3 mod 5 should be the same as 3A1 plus 13A2 plus 20E3 mod 5, because we want to find out when this scheme cannot catch the error, right? So if the error will not be count if the check digit is the same. So that's why we need to simplify this equation. Then you can see that this 3A1 and 3A1 is the same part, so you can just cancel out. And 13A2 and 13A2 is the also same part, so you can cancel out. Then what you can get is 20A3 and 23, so you can just write down as 20A3 minus 20E3 mod 5 should be 0, right? So it means that 20A3 minus E3 is a multiple of 5 when error will not be caught. Okay, is there any question before going further? Okay, then let's think about this number. So here, this number 20 times something, if you think about it, then actually 20 is already multiple of 5, right? 20 is 5 times 4. So whatever the number A3 minus E3 is, the whole number is always a multiple of 5, right? It means that whether you just give the correct number on third position or some incorrect number on third position, your check digit doesn't change it, right? So it means that it is always true, right? True, since 20 is multiple of 5. So therefore, this scheme or this check digit, okay, always does not found single digit error on third position. So answer is just, yeah, this check digit doesn't catch, will not catch the single digit error on third position. Okay, does it make sense? So in the actual exam, I will give you some problem like this and on the workout part. And to get the full credit, you need to write down all those correct code, incorrect code, check digit on incorrect code, and comparing and the conclusion to get full credit. So I already mentioned in the program that you need to write down those things, but you need to fill out to get the full credit, right? Okay, do you have any question? Great, thank you, Abid. And then next question. So in number 5, does the given scheme of check digits serves its purpose well or not? Yes, so no, in this case, Dawson, yeah. So what Dawson asks me that, so if it was 5 times A3 minus E3 mod 20, then it would be A3 minus E3 mod 4. Yes, that's correct. Because if 20 is in the divisor side, then definitely, yeah, A3 minus E3 should be the mod should be something multiple of 4 to make it 0. Yes. Okay. And serves its purpose well and explain it based on your number 4. So to see this, first of all, what is the purpose of check digit? It is just nothing but to detect possible error, right? However, from number 4, we know that it does not catch error on third position. So it not serve its purpose well. So what is your question? What does it say after given in the question? So what I said in the question is number 2, 5. Lastly, does the given scheme of check digits serve its purpose well or not? Explain your opinion based on number 4. That's the full question. And answer is here. The purpose of check digit is to detect errors. Yeah. However, from 4, you can see that it does not catch error on third position. So it does not serve well on its purpose, right? So here, I hope that you can just remember what is the purpose of the check digit.
The way the question was phrased was a little confusing when I read it, for sure. I don't know if anyone else was confused. I wasn't quite sure that's what it was talking about. So yeah, I was a bit confused.
Yes, sorry about that. So yeah, so what I want to ask in the number 5 is that just evaluate your check digit whether it caught error well or not. So that's my purpose. But yeah, my statement is a little bit unclear, and it also contains some typo on purpose. So yeah, I will make it clear on actual exam. Okay, thank you, Joanna. Okay, is there any other question or comment? Yeah, so in the actual exam, I will say that, yeah, evaluate whether the check digit serves its purpose well or not, okay? Yes. Yes, so Dawson has questioned that, so if it was 5A3 minus E3 mod 20, then it will be A3, E3, I3 minus E3 mod 4, yes. And the answer would be that it doesn't serve its purpose well because it catches error at the third position. Yes, so it catches at least some errors on the third position, right? So yeah, you can say that. But in case of, in the original case, it does not catch any error, right? But in case of your suggestion, your case, it catches at least some small errors, which are A3 minus E3 is not the multiple of 4. So yeah, we can say that it served well because, check digit, at least, yeah, check digit needed to at least one errors can be caught in your situation. So, oh yeah, so I will explain that point also. So how are you getting mode 4? So okay, so let's see this example. So say 5 times A3 minus E3 mode 20, and I just want to show that this is the same as A3 minus E3 mode 4. So to see this, yeah, you can think about this is some number, right? So here A3 minus E3 is just some number. We don't know what the number is, but just some number x. Then if 5 times x is a multiple of 20, then it means that, you know, x is just, if x is just multiple of 4, then 5 times x is multiple of 20, right? Because we, for example, if x is 4 times some number y, then 5 times x is 5 times 4 times y, which is 20y, right? So definitely it is multiple of 20. So 5 times x is a multiple of 20 is the same as x is multiple of a multiple of 4, right? So yeah, that's why we can just get rid of it. And in the usual situation, so for example, if we just change doesn't example with 6, then it means that 6x is a multiple of 20, a multiple of 20. But here, 6x is the same as 2 times 3x, right? And we know that 3 cannot divide 20, but 2 can divide 20, right? So if you just multiply 10, then you can get 20, right? So if x is a multiple of 10, then x is just 10 times y, then or the calculation is just 2 times 3 times x is equal to 2 times 3 times 10 times y. So it is just 20 times 3 times y, right? So in that case, we can say that actually 3 times A3 minus E3 is mod 4. And one more time in here, 3 cannot divide 4, right? So if it is the multiple of 4, then the x should be multiple of 4, right? Because 3 doesn't factor, is not a factor of 4. So in that case, you can just get rid of it as, oh, here, it should be 10, sorry, in case of 6. You can just write down it as A3 minus E3 should be mod 10, right? So that's why I mentioned GCD in the our class. So the greatest common divisor of those two numbers. So if you just think about greatest common divisor of 6 and 20, then you can get 2 as your greatest common divisor. So you can just divide both sides by your greatest common divisor to get this 3 and 10. Then again, 3 and 10 has greatest common divisor, which is 1. So you can just get rid of your 3 to get the conclusion. Great, thank you, Katie. And then let's move on to number 3. So here, number 3 is about what are the definition of single digit error? And adjacent transposition. And jump transposition. So yeah, the reason I put it in the review is that, yeah, in the actual exam, I will give you some program matching the definition and, you know, each word, right? So, you know, you don't need to, memorize all the definitions, but if you just read it and figure out which is connected to which word, then you are fine. So in the case of single digit errors, is that just each error occurs when an incorrect digit is entered. I write down, in the solution, I write down it more clear, more, computer typed word. So don't worry about my writing. And adjacent transposition is, it is just some error occurs when adjacent digits, adjacent digits entered in reverse order. Yeah, that's sad, Abby. But maybe you can get the, you don't have any error on this exam 3. So don't worry too much about the exam. And jump transposition errors occur when digits that are separated by another digit are entered in reverse order. So again, you don't need to memorize, just words in the definition, but what you need to do is just in the actual exam, you will see that some matching problem about division of those errors and the name of the errors, and just matching that, the name and each definition, then you are fine, right? Okay, so move on to the number 4. In number 4, the driver license of Florida is a form where we know that this is form XXXX, XXX, YY, DDD, and where XXX is about based on name, and this YY is just last two digit of birth year, and this DDD is just coded from month and day of your birth, and this DDD is determined by male is 40 times M-1 plus D, and female the same formula, but plus 500, right? And N is some overflow digits, right? So yeah, actually in the exam, you are asked to, get the information from given number or transform your birth date into the, this code in YYDDD. So first problem is, what is the gender and birthday of 97345? So gender and birthday of 97345. So here from 97, we know that YY is just 97, means that birth year is 197, sorry, not 99. Because it is a little bit, awkward. I'm not sure, but I don't know that whether someone who born in 1897 will still alive. But yeah, so just infer that 99, 97 in the actual exam also. So birth year is 1997, and in case of the 3445, to get 345, first of all, to get DDD is 345, and what you can do is divide it by 40 to get remainder, right? Get the quotient and remainder. And to do this, it is 4 times 8 is 332. So it is just, 345 is equal to 40 times 8 plus 25. So here 8 is just n-1 and 25 is just birth date. So from this, you know that birth month is 9 and day is 25. So it is birth date is 1997, September 25, or just write down, yeah, September 25. Okay. Oh, here I just said the usual MMDDYOY form. So, okay, in that form, it should be 09251997. Does it make sense? Or do you have any question? Okay, great. Then let's do it number 2. So what is the YYDDD of Jane Doe? Oh, yeah, gender is male. Yes. Thank you, Joanna. Yeah, gender should be male. Yeah, I need to put it here. Okay. I just get months because, okay, give me a second. I just put everything. So how I got the months is that from this, from the formula, we know that this number DDD is based on 40 times something plus date, right? But if you think about date in the calendar, date should be from 1 to 31, right? So every date should be less than 40. So D should be the remainder of the number DDD, right? When you divide it by 40. And the quotient should be m minus 1, where m is the birth month. So here quotient 8 is m minus 1. So m minus 1 is 8, means that m should be 9. And does it make sense, Abby? And for Katie, do you assume that it is male because the DDD digit, yeah, would have been significantly higher due to the Fermat equation? Yes. No. Some number minus 1 should be 8, right? So what is the sum number? That's 9. Yeah. So yeah. So in case of the gender, if you see that some number is less than 500, then it is male. But if it is greater than 500, then it is female. Yes, so since DDD is less than 500. Okay. Great, thank you, Abid and Katie. Okay, then let's do it next example. So here, YYDDD of Jane Doe, whose birth date is October 20th, 1987. So here, YY is just 87, right? Because we just lost 2 digits of the years. And DDD is 40 times M is October, so it is 10 minus 1 plus 20. But here she's a female, right? So that's in the information. So you need to add 500. So it is 40 times 9 plus 20 plus 500. So 360 plus 20 plus 500. So it is 880. So the answer is 87880. Do you have any question? And lastly, does 20039 okay, is 20039 valid? So to see this, yeah, check about the, how can you check that whether this, driver license is valid or not? And to see this, you can see that maybe at 12, we cannot have, answer on 12. So maybe it is 1912. Yeah, maybe there are someone who is still alive when born in 1912. 12. So that may be valid. But in case of 039, it means that 39 is just 40 times 0 plus 39, right? So it means that this is just 40 times m minus 1 plus date. So m should be 1 because m minus 1 should be 0. And d should be 39. So his birth date, or it is gender is male because it is less than 500. So birth date is January 39th, 1912. But that's not make sense because January doesn't have 39th day, right? So that's why the answer is no. It is not valid. Does it make sense? Great. Thank you. And let's deal with the number 5. So number 5 asks you that can you convert the decimal number 79 79 into the, it is decimal number, into the binary number. And again, convert the 1110, 1010, 1010, which is binary, into decimal number, right? So that's the question. So in case of 79, you can do it by, I just tell you how to do it. So divide 79 by 2 to get, it is actually just divide it by 79, then 2 times 3 is 6, and 2 times 9 is 78. So remainder is 1, and what you can get is 39. So remainder is 1. And again, you can divide this 39 by 2 to get is 19. Remainder is 1. And if you divide it 19 by 2 to get, it is 9. Remainder is 1. If you divide 9 by 2 to get, it is 4. Remainder is still 1. But 4 is divisible by 2, so it is remainder 0. And 2 is definitely divisible by 2, so it is remainder 0. So just write down it from here to here. And you can get is 1, 0, 0, 1, okay, 1, 1, 1, 1. That's the binary expression of the 79. Right? And in case of the, convert from binary number to decimal number, what you need to do is, okay, I will just put it in a little bit bigger so that you can see it. 1, 0, 1, 0, 1. Oh, okay. Sorry, I don't know why, but my iPad pen doesn't work. Oh, no. Hey. Oh, great. Yeah, now got it. Sorry about technical difficulty. So 11101. Okay. 01 01 01 0. So here, okay, so I got number 1001 here by dividing 79 by 2, and then you can get the quotient and remainder, and divide the quotient by 2 again to get some quotient again and remainder. And you can just do this process when you got the number 1 or 0 in the final, right? Then all you need to do is just writing down the number 1 or 0 in the remainder, from starting from the the last one to the top one, right? From bottom to top to get this number. Okay, great. And to deal with, change your binary number into the decimal number, just write down the 2 to the 0, 2 to the 1, which is 0, 2 to the 3, 2 to the 2 first, 2 to the 3, and 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7, 2 to the 8, 2 to the 9, 2 to the 10, 2 to the 11, right? So just write down, from 1 to 2 to the 1, 2 to the 2, 2 to the 3, and so on the digits, right? From right to left. Then all you need to do is just add when your position has 1. So here you can see that 1 are in those positions. So what you need to do is just 2 to the 11 plus 2 to the 10 plus 2 to the 9 plus 2 to the 7 plus 2 to the 5 plus 2 to the 3 plus 2. And 2 to the 11 is 248. 2 to the 10 is 124. 2 to the 9 is 500. Is it 520? Yes, 520. And 2 to the 7 is 128. And 2 to the 5 is 32. 2 to the 3 is 8 plus 2. So add all together, this is 10, this is 160, and so this is 170, so it is, and this is 3072 plus 520 plus 170. So yeah, it is, by calculator, I got 3754. So use your calculator when you add all those numbers, right? But so all you need to do is just write down the, 2 to the exponent on the, on the each digit, then add all those numbers if your digit has 1. Oh, okay. So again, I'll scroll up. So, okay. I just write down it, okay? So what I did is just add those numbers. So the answer is 3754. Can you see Katie or? Okay, great. Okay, do you have any question on number 5? '79 is 1001111, not 111100. Because it starts from bottom with this 1 to the top. And Lindsay question, yes. Do you start at 11 because you need to include 0 as the last one? What is your question, Lindsay? I didn't see where 11 starts.
She's saying that when we're doing 2 to the 11th.
Okay. Oh, in the leftmost position. Yeah. So I just start with rightmost position first because sometimes we don't know what the position left is, right? Because it already determines from the ranks of the whole binary string. So just start with the rightmost position with 1, and next one in the left to 2, and next one in the left to 4, and so on. Thank you, Joanna. So I just start from, here the direction is important. So in case of the conversion from decimal to binary, start from bottom, including your last quotient, which is 1 or 0, to the top. And in case of the changing binary into the decimal, start with the right point and just put it 1 to 4, 8, 16, and so on. Right? That is much more. Maybe you can start with left one, but it is a little bit, you may have some mistake to determine what is the position for your leftmost point. So just start with the right one. Okay, do you have any other question? Okay, then let's move on to number 6. So in number 6, we have a binary code, which is 00000 and 11010 and 101010 and 001101. And the number A asks us, what is the received message? 111010. It is just received message. Should be decoded when we use the nearest neighborhood decoding, right? To get the nearest, to decode using the nearest neighborhood decoding, what you need to do is just find the code word, which is the nearest, right? The received message. And to find this, what you can do first is just, as we did in the example, you can just write down all those numbers, 0000000, 110101, and 101010, and I write down it here, and 001101, and write down your code word 111.0.10, 111.0.10, and 1010, 1010, and you can just compare their distance, which is Hamming distance, we know, and distance is just nothing but just the number of different digits, right? So here there are 4 different digits, so distance is 4, and here there are 4 different digits, so distance is 4, and here, oh, I did mistake. Okay, so I will just put again 101010 and 111010. So here difference came in this position only, so its distance is 1, and here difference came in the last position. Okay, so it occurs in the 5 positions. So 4415. So from here, the nearest code is 101010. So the answer is 101010, right? Yeah.
Yeah,
Because,
it says it's wrong.
because I put the wrong number. I'm so sorry. I just changed it. So yeah.
Oh, cool.
Yeah. Sorry about that. But yeah, the web sign is wrong. So yeah, they will change it after the session. Sorry about that. I just made it very quickly. So yeah, the correct answer is 101010. Sorry. Yeah. Okay, in the number B, what is the weight of the code C? Okay, before going on. Maybe picks. And what is the weight of code C? And how many errors it can detect? And how many errors it can correct? So here, if you think about the weight, then first of all, you need to ignore, okay, so to do this, you need to ignore on the 0 code, and this code has 4 ones, and this code has 3 ones, and okay, I will just write down 4 ones, and to distinguish 1 and 3, and 3 ones, and 3 ones. So from here, the smallest number among those, 433 is 3, right? So weight is just mean of 334, which is just 3. So in that case, so that's our T, and we run that T minus 1 errors can be detected. And also I will put it in the above. So give me a second. T minus 1 error can be detected, and if T is, if T is odd, then T minus 1 over 2 errors can be corrected. And if T is even, then T minus 2 error over 2 errors can be corrected. This is 2. So here, just put your t in those equation, then t minus 2 means that detect 2 or fewer errors and correct 1 or fewer errors, right? So here t minus 1 is 2 and this one is 1 because our case is odd. Okay, do you have any question? So please remember this, formula for the ability of your code. This formula will not be given on the exam, so you need to write, at least memorize, yeah. And on number C, add 2 strings, 1, 1, 0, 1, 0, 1, and 1, 0, 1, 0, 1, 0. Yeah, the formula on here is not given on exam. Yeah. So, and yeah, that's what I explained in the, in the supplement on 17.4. So here, adding to binary string is nothing but change if you have some difference, then change it into 1. Oh, sorry. And if you add the same number, then change it into 0, right? So for example, 1 plus 1 is just 0, and 0 plus 0 is also 0, but 1 plus 0 is 1, and 0 plus 1 is 1. So you can do the same thing on each digit, right? So here, 1, 0, which is deeper, so it is 1, 0, 1 is deeper, so it is 1. Again, 1, 0, and 0, and 1, 1, and 1. And 1, 1 is the same, so it is 0. So that's why I mentioned that it is not exactly addition, but it is actually called exclusive OR. But I will do not, go to that too far. But so just yeah, remember that if you have same number on the same digit, then it is just 0. So answer is 0, 1, 1, 1, 1, 1. Okay, do you have any question? Yes, so in the exam, I will just ask write this number C. So I just give you 2 strings with the same length and just say add it. Then when you can just give this. So what I'm worried about you is just thinking that 1, 1 is 1, 0, but no. In case of string, just get rid of this carry, right? How did you know the weight of code? Oh, okay, that's a good question. So weight of code is just the minimum number. So, okay, I'll just put it here. Weight of code is just the minimum number among all codes, minimum number of ones code words. Code words. So it is minimum number 1 on all code words. So here it has minimum all non-zero code words. So okay, non-zero is important. So here non-zero code words are three. There are three non-zero code words. This 110101, 101010, and 001101. And this one 110101 has 4 ones. And the other one, 101010 and 001101 has 3 ones, right? So 3 is the minimum number between among 4 and 3, right? So that's why we can get rate of the whole code C is 3. Does it make sense, Karen? Great. Okay, let's move on to number 7. And I hope that, yeah, it will be, I think that that's the most difficult part in this exam. So please be careful about it. So in number 7A, do the delta encoding on 23, 25, 27, 30, 29, 29, 18, 17, and find compression rate. So here, just start with your first number. And second number 25 is greater than 23 by 2, so it is just 2. And 27 is greater than 25 by 2, so it is just 2. And if you add 3 to 27 to get 30, so you can just write down 3. And if you add negative 1 on 30 to get 29, so it is negative 1. And 29 and 29 is the same, so 0, because it doesn't change it. And if you just add negative 11 to get 18, so it is negative 11. And if you add negative 1 to get 17, so it is negative 1. So this is delta code encoding. Delta encoding, sorry. And if you just count the vectors you use for this encoding, is that 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, right? 13 letters are used. So the compression rate is, and here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16. So it is 16 minus 13, 16 letters over 16. And yeah, negative should be counted as a letter because, negative something is definitely different with positive one, right? So if we didn't put negative sign, then we cannot decode it properly, right? So that's why we count it as a letter. So it is just 0. Yeah, I think that your calculator, I've got 0.1875. Or you can write down. So yeah, again, yeah, I will put some, percent notation, or I put some something say that, yeah, just round it to decimal or something like that. So I don't worry about the rounding up. Okay, so do you have any question? Yeah, just the number of original vector minus the new vector over the original vector. Yes, that's the usual formula. And give me a second, I just put my iPad. Because my Apple Pencil have not much battery, so I will change it again. So it is already original letter. No. Over number. Right. Okay, then let's move on to Huffman coding. So there are some students who are very, had difficulty on Huffman coding. So yeah, so I will just write it. So here what you have is A is just 0.05, B has probability 0.32, C has probability 0.14, D has 0.18, E has 0.23, F has 0.08, right? Then first thing you need to do is just sort it from the least likely to the most likely. So here the least likely is A, so you just put A first, 0.05. And next least likely is just F, which is just 0.08. And the next one is C, 0.14. Next one is D, 0.18. And the next one is E, 0.23. And the last one is B, 0.32. And that's the first. Then what you can do is just concatenate the leftmost two characters and add their probability, their key, and sort it again. So that is the important part. So here we need to concatenate this AF first, right? And if you just add 0.05 plus 0.08, then what you can get is just 0.13. But 0.13 is it is just least likely among all others, right? So here, what you can get is 0.13, and the others are the same. And then again, we can just concatenate this. Oh, sorry, AF. Thank you, Katie. This should be AF. Yes. Yes. And again, if you just concatenate them to get AFC, which is 0.27, but 0.27 is definitely greater than this 0.180 or 0.23, but less than B. So by sorting this, we can get D in the leftmost, E in the next, 23, sorry. And AFC and B, 0.32. So I'll put it in the next page. DE, A, FC, and B 0.18, 0.23, 0.27, 0.32. Then again, just concatenate the leftmost two characters. Then if you add this, then what you can get is 18 plus 23 is 41. And 0.41 is actually greater than or among others, right? So you need to put it in here in the rightmost point. So it should be AFC 0.27, B 0.32, and DE 0.41. And then again, add those two numbers to get AFCB is 0.59, but it is greater than DE, so that's why I put DE in the right left side. Then if you add this number again, then what you can get is DEAFCB with probability 1. Okay, is everybody get it, or do you have any question on this procedure? Yeah, it is always equal to 1 because these numbers are all the probabilities or frequencies which came up in the specific text. So yeah, the addition should always equal to 1. And if it is not equal to 1, then there is something wrong. Great question, Katie. Okay. So, and then what you need to do is just generate 3 and label it by 0, 1, 0 for left one and 1 for right. So for example, we have DEA FCB, but actually this is from DE concatenate with AFCB, and AFCB is concatenated from AFC with B, and DE is concatenated from DNE, and AFC is concatenated from AF and C, and AF is concatenated from AF. So here, just write down 0 for the left side branch and 1 for the right side branch. So here, just 0 for left side branch and 1 for right side branch, 0 for left, 1 for right, 0 for left, 1 for right, 0 for left, 1 for right, 0 for left, 1 for right. Then the last one is just write down it for each number, each character. So A is 1, 0, 0, 0 to get A, right? So you get 1, 0, 0, 0. And B is 1, 1 to get B. So B is 1, 1. And C is here. So 1, 0, 1. Oh, okay. I'll draw it a little bit slower. Okay. So, okay. I'll just throw it in there here. So we start with the EAFCB, right? And if you just this is just basically undoing what we just did. Yes, that's great observation, Karen. Yeah. So what we get this concatenation is actually came from DE concatenate with AFCB, right? So I just put DE and AFCB in here. Then again, this DE came from D concatenate with E. And this AFCB came from AFC, we concatenate with B. So AFC with B. And this AFC is concatenated from AF and C. So that's why I got AF and C. And lastly, AF came from A and F. And the spread says that, do we arrange them by alphabetical order or value? No. So yeah, if you just take it in the WebAssign or, WebAssign or eCampus, then I will definitely give you some, each blanks for each numbers, each letter. So A with blank, B with blank, C with blank, so that what you need to do is just type down those, codes in each blanks. And the reason I write down in alphabetical order is to just show you the result. And C is 101. So here again, if you have 3, then just put 01, 01, 01 for left branch and right branch. And D is 00. And E is 01. And F is, okay, F is a little bit top. So let's, okay, F here, F came from this. So 1001. Okay, so that's Huffman coding. Do you have any other question? So to get the free credit, then what you need to do is just write down, this sort, and yeah, write down this 3 because 3 shows what you did, and the last answers, right? Okay, then let's move on. Number C. Use the compression algorithm given by, okay, number C says that given by C is 0, A corresponds to 10, T corresponds to 110, G corresponds to 111. To encode the message CAT, GT, GAC, and decode some wrong binary string 1010, 0101, 01, 00, 100, 110, and 1. So yeah, encoding and decoding are just change a letter with a given code. So C change it with 0, A change it with 10, and T change it with 110, G change it with 111, T change it with 110, G change it with 111, A change it with 10, and C change it with 0. Right? So just be careful about the order and do not missing any word, any character in the original message, then you can get the answer. And to decode this, just see just read character from left. So here, first character is 1. So maybe it is the first letter should be one of the ATG. And the next character, including next character, you got 10. So definitely this is A. So you can just write down A in here. And again, we start with 1. So it will be one of the letter ATG. And if you just read the second letter, then still you can 1, 0. So what you get is A. And the next one starts with 0, but there are only one letter start with 0 is just C. So it is just C and done. And start with 1 and 1, you get 1, 0 for the next one. So you got A. And for the next one, you still have 1, 0. So you got A. And the next one, you still have 1, 0. You got A. And the next one starts with 0. So you got C. And again, next one starts with 1, 0. So it is A. And 0 change it to C. And here 1 and start with second one is also 1. So it will be 1 over T or G. And it is determined by the next one. So 1, 1, 0 is just T. And lastly, 1, 1, 1 is just G. Right? So in case of this compression algorithm, decoding and encoding is nothing but just change the assigned code word into the letter or assigned letter into the code word and concatenate, right? Concatenate. Do you have any question? Okay, now we are dealing with the most difficult one in here. So use the 3 ciphers we learned in chapter 17.4 to get decode, encode and decode some words. So, okay, so let's start with the Sigil cipher. So I didn't put the number for translation. So, okay, so let's translate key is 4. Okay. Shipped by 6 letters. That's my mistake. So I'll put it in the review after this session. Sorry about that. So if you just do 6 letter, shipped by 6 letters, then what you can do is, first of all, in case of encode, the code of region, yeah, then this L correspond, first of all, what you need to do is just write down the code which are assigned to the each letter. So L is the 12th letter, so it is 11. E is the 5th letter, so it is 4. A is the first letter, so it is 0. So always we start with 0. So that's why I just, get it is 1 from their position, their relative position, and G corresponds to 6. U corresponds to 20. So in the actual exam, I definitely give you the code word where what we write, use in the lecture notes. So I will definitely give you just a table about A0, B1, C2, D3, and so on, right? So don't worry about that table. Yeah. Yeah, it was shift 11. Sorry, yeah. You're right. Thank you, Joan. Yeah. 11. Oh, I didn't see. Yeah, I didn't catch it. Yeah, thank you. And E is 4, and O is 14, and F is 5, and L is again 11, 4, G 6, E is 4, N is 13. Okay. Just put 4, 13. D is 3, right? And translate it's 11, so shift by 11. And what you did is just, what you need to do is just adding 11 for each number, right? So 11 plus 11 is 12, 11 plus 4 is 15, 11, 17, 31, 15, 25, 5, 22, 15, 17, 11 plus 4 is 15, 24, 14, right? And here, just take mod by 20, mod up by 26. So, 22 is less than 26, so you don't need to anything, right? Okay, I write down it by oracle, 22. And 15 is just less than 26, so it is just same. 11 is just less than 26, same. 17 is same, but in case of 31, it is greater than 26, it is actually 5. If f is 5, wouldn't it shift to 16, not 5? Oh, yes, thank you. 16. Yeah. Thank you, Kay. I just missed it. So don't miss it in the exam. And in the exam, I will definitely not give such a long sentence. So don't worry too much about the length of the sentence. So, and 15 is just 15, and 25 is less than 26, so it is still 25. 16, 22, 15, 17, 15, 24, 14. So all numbers are the same. So what you need to do is just change it into the letter, and 22 is corresponds to W, and 15 is P, 11 is L, 17 is R, 5 is F, 15 is P, 25 is G, 16 is Q, 22 is W, P, R, P, 24 is Y, 14 is O. So the encoded message is WPLRFP GQ WPRPYO. Oh yeah, I will give you tables. So what I actually see is this table. So yeah, if you see the rational, then I will definitely give you this table, right? From A correspond to 0, B to correspond 1, and so on. So yeah, it will be definitely, offered in the exam. Yes, Katie, that's correct. Exam mode 26 because the amount of letters are just 26 letters, right? So that's why we just mod out and take the letter corresponding to the remainder. Okay, then let's deal with mice. Here again, position is M for 12, I for 8, C for 2, E for 4, and shift by 11. But in this case, when you decode it, just shift by negative 11, not the just 11, right? So in case of encode on Caesar cipher, you need to add the number 11, right? But in case of the decode, you need to subtract the given number 11, right? So actually that's 11 and 19 for the decimal. So yeah, I just did in the very unclear way, but this encryption key 11 and decryption key 19 for decimation cipher, but okay, so yeah. So okay, so but anyway, so what I just want to say is that it is just taking subtraction on your key. Yeah. So yeah, so in the usual question, I will definitely actually yeah, I admit that this is a little bit unclear question. So in the usual case, seizure cipher will be only delivered with one key, only one key, shift by some number. So and if I say yeah, if the exam says that please decode with the key some number, then it will be yeah, just subtract it. Yeah. Sorry for yeah unclear message. And then, yeah, so if you just do it by shift by -1, 11 in this case, then it is -3, 1, -3, -9, and -7. And again, mod up by 26. So if you have some negative number, then just add 26 so that you can get some positive number, right? So 1, you don't need to do anything because 1 is in the numerator. But in case -3, just add 26 to get 23. And in case of -9, add 26 to get the 17. And in case of -7, just add 26 to get 19. Okay, I put all the things a little bit up. Then the final word, final character you can get is actually B23 X 17 R T, right? Okay, so in case of seizure cipher, just one thing should be remembered. So when you encode, then add your key or shift your key by adding. But when you decode, then shift your letter by subtracting. That's all you need to remember for seizure cipher, right? Okay, then next, I will do the decimation cipher. So here, okay, I will just copy this thing. So yeah, position is the same. So, but in this case, we have encryption key, which is 11, and decryption key is 19. So in case of decimation cipher, whether encode or whether decode, what you need to do is just multiply your key. So in case of encode, just multiply your encode key. So here it is post times encode key. And what you can get is 11 times 11 is 121. And 4 times 11 is 44. 0 is 0. 6 times 11 is 66. 20 times 11 is 220. 44. 14 times 11 is 154. 5 times 11 is 55. 11 times 11 is 121, 44, 66, 44. 13 times 11 is 143, and 3 times 11 is 33. Then just to mod out by 26, then what you can get is, here I think I need to use the calculator again. 27 and 44 more 26 is 66 more 26 is 14, and 200 was 12, and 44 more 26 is 18, and 154 more 6, and 55 more 26, and 17, 18, because we already calculated it on the previous letters, and 14, 18, and 143. 46 is 13, and 7, right? Then all you need to do is just change it into the letter. Then again, using your table, you can conclude that it is just R S A 14 O 12 M 8 S 24 Y 3 D and 17 R S O S and 7 H. Let's say O N S Y D R S O S and H. And in case of decode, again, just multiply, multiply encryption key, and again, multiply decryption key, right? So here, decryption key is 19. And here, so MICE is from, we know the positions are 12, 8 to 4, and position times decryption key. Your decryption key is 19. So if you just multiply 12 with 19 using your calculator, then what you can get is 228. 8 times 10 is 52. 2 times 19 is 38. 4 times 19 is 76. And just mod up by 26 to get 20, and 22, 24. So again, using table, it is U, U, W, M, Y. Do you have any question? Oh, can you hear me or? Oh, sorry. So what I did in decimation cipher to decode it, okay. So decode it is just, yeah. What I did is just write down position and multiply decryption key. It is 19. Then mod up by 26 to get this number, these letters, right? So the difference between the seizure cipher and decimation cipher is that in case of seizure cipher, we just add or subtract to get the decoded. So in this case, encode is just add keys, and decode is just subtract key. But here, decimation cipher is encode is just multiply encryption key and multiply decryption key for decode, right? That's the big difference. So in the actual exam, I will give you table like what we did in the lecture notes. So for example, in the lecture note, you can see that we see such a table, right? So for example, it is a table for the decimation cipher, and this is also table. This is for table vision cipher, or this is table for seizure cipher. So yeah, all such a table will be given. So what you need to do is just follow the procedure to get the letters, right? Okay, then let's deal with the last one. So which is the visionary cipher. So again, I already had copy, right? So I just copied this. So in case of visionary cipher, one thing you need to do is just use the code word to get the number. Here we use the keyword is right? So add course word in keyword. So here we know that it corresponds to MATH, 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 MA. And we know that M corresponds to the, okay, I really need to check it, strap, and A corresponds to 0, T corresponds to 19, and H corresponds to 7, and it is just, repeated for 12, 0, 19, 7, 12, 0. Then in the visionary cipher, what you need to do is just, in case of encode, you need to add, right? Oh, sorry. So yeah, that's keyword. And just take sum to get 11 plus 12 is 23. 4 plus 0 is 0. 0 plus 19 is 19. 6 plus 7 is 13. 20 plus 12 is 32. 4 plus 0 is 4. 14 plus 19 is 33. 5 plus 7 is 12. 11 plus 12 is 23. 4 plus 0 is 4. 6 plus 19 is 25. 4 plus 7 is 11. 13 plus 12 is 25. 3 plus 0 is 0. And lastly, mode up by 26. So 23, 4, 19, 13 are okay. But in case 32, just subtract 23 to get 6. And for 33, just subtract 26 to get 7, 12, 23, 4, 25, 11, 25, 3. So the final letters corresponds to using the table X, E, 19 is T, 13 N, 6 G, 4 E, 7 H, 12 M, 23 X, E, 25 G, 11 L, 25 G, 3 D. So X, E, T, N, G, E, H, M, X, E, G, L, G, T. That's encode, and in case of decode, then what you need to do is subtract code word in keyword. So in that case, MICE is here, but it is matched with MATH, and you know that MICE is 12, 8 to 4, and MATH is 12, 0, 19, 7. So subtract it, you can get 0, 8, negative 17, and 11. Then mode up by 26 to get 0, 8, 9, 11, which is AI, 9 is J, 11 is R. Okay. Put it in the okay. Oh, subtraction, yes. Thank you, Katie. Yeah, I had a lot of mistake. Okay, yeah, it should be -3. So it should be 23, and 23 is X. Thank you, Katie. Yes. Okay, do you have any question on Cypher? Okay, then let's deal with the number 8 and number 9. Those are all much more simpler than Cypher programs. So here you receive message 1111 and it is encoded by circle Venn diagram method. Then find the original one. If it has an error on a single digit, And to do this, what you need to do is just draw your circle Venn diagram. Then put your number here, 1, 1, 1, 1. I just choose A1, A2, A3, A4 here, A1, A2, A3, A4, and C1, C2, C3 should be here, here, here. And if you just figure out that whether each circle has even or not, then all circles has the odd number, right? So all circles are wrong. Then what you need to change is the number inside of the common region of 3 circles. So you need to change A3 into 0. So the correct message is 1, 1, 0, 1, 0, 0, 0. So here, change the number in common region. That's the point. Do you have any question? No, for example, if it was 0, then you need to change it to 1. So I just change it 1 to 0 because it is given by 1. But if it is given by 0, then you need to change it into 1. So let's do some examples. Okay, so here, think about the case that 1, 0, 0, 0, 0, 0, 0. Yeah, it already have number like 0 and 1 because it is already binary string. Yes. So then what you have is 1 here, 0, 0, 0, 0, 0, 0. So in this case, this one is wrong, and this one is wrong, and this one is wrong. This one is okay, right? Because the adding everything, you can 0. So the common region is here, which is inside the 1. So this 1 should be changed into 0, and all the message should be 0, right? So yeah. Do you have any other question? Yeah, okay. So if your number is A1, A2, A3, A4, C1, C2, C3, then your Venn diagram should have 2 circles in the top and 1 circle in the bottom. Then A1 should be in the, the common region in the top. A2 should be here. A3 should be middle. A4 should be here. Then put C1, C2, C3 in this order. So yeah, you need to memorize this picture because it is not offered in the exam. Okay, great question. Okay, and lastly, number 9, then we are done. So given G plus 4 code is 1, 2, 3, 4, 5, 6, 7, 8, 9, and the national area of zip code is just this part, 1, and the sectional facility number is these two number, which is just 2, 3, and local delivery area number is this. This, oh, it's not the same. Okay, this 4, 5. So it is just 4, 5. And 4 number used for first person is this last 4 digit. So honestly, I don't like such a program like just memorizing the code, but it is required in the exam share. So I will give you some examples on G code and figure out which one is the which one denotes which part, right? So that's number 1. Okay, do you have any other question?
I have a question, Professor.
Okay.
So when I was working on the Huffman tree on the homework, you know how we assigned the zeros and the ones based on like the I say like heavier side or like the greater side. So on my question, I had the same, like they were the same. So how would you assign the 0 and the 1 if they're worth the same? Because I had assigned the 0 on the left and the 1 on the right, but it was wrong. So then I flipped it and it was 1 and 0, like 1 on the left and then 0 on the right. So will that be on the exam? Like, do we need to worry about that?
Okay, Karen, can you hear me?
Now I can, yes.
Okay, great. So for example, let's deal with Huffman tree you deal with. So in case of the same thing occur, then first of all, in the exam or the probability should be different. So that's what you don't need to worry about. But in case of the when they are same, then just follow the the smallest one first. So okay, so Eugene, you're number 7 or 8? Did you remember it?
On the homework?
Yes.
It was number 7 on the homework.
Okay, got it. Yeah, so let's deal with number 7. So A, B, C, D, E, F, G, and A is 0.25, B is 0.15, C is 0.025, D is 0.015, E is 0.215, F is 0.17, G is 0.2. So here the smallest one is D. So you need to write down D here, 0.015 in here. And next smallest one is B. So 0.15. And next smallest one is F, 0.17. Then G, 0.12. And A, no. Oh, sorry, I forgot to write down C because C is 0.025. So it is much more smaller than B. Okay, so C should be here, 0.25. A should be 0.2. E should be first instead of A. A should be 0.225. G should be 0.2, right? Then adding this, you can get 0.04 with DC, but still small, so you can just use the other numbers. Then add those two, you can get DCB 0.19. And in this case, 0.19 is greater than F, but still less than G, so F should be here. 7 G E A G G. Oh, this G should be deleted. Sorry. Yeah. And it's because G is in here. And then here, FDCB is 0.36, and 0.36 is greater than anything else. So you can just write down it in the here. Okay. And write down the others as GEA 0.2, 0.215, 0.225, and just add GE to get GE 0.415, but it is definitely greater than among all. So it should be here. And A is 0.225, FDCB 0.36. Then add those two to get AFDCB, GE, and adding those two to get the final one. So I think there is nothing the same thing came up, right?
Yes, correct. I just wanted to make sure that that wouldn't happen during the exam, so that way I wouldn't get confused. Like if
okay.
they were gonna weigh the same.
Okay, yeah. So yeah, in the Huffman-Tree, if they are the same probability, then we cannot decide it uniquely, right? So definitely that case is not happening in the exam and or other homeworks. Yeah. Okay. That's a good question. And do you have any other question?
No, I'm okay, thank you. I do have another question about your office hours. Are you still gonna have regular office hours tomorrow?
Yes, so tomorrow I will have regular office hour as usual from 3 p.m. to 4:30. So yeah, please let me know if you have any question, or yeah, even if you cannot make it in office hour, then just email me that, hey, can you just Zoom right now? Then usually I think that in Monday I'm available for except in the morning. So yeah, just email me if you need me.
Okay, thank you very much. And then as always, we can send you emails throughout the day, right?
Yes, I will send the email. Yeah. Mm-hmm.
Okay, thank
For
you.
the announcement. Okay, thank you. Mm-hmm. Okay, is there any other question? Okay, then I will post it in the eCampus, and thank you very much for taking this 2-hour review session. Okay, have a great weekend and have a good luck on your exam.